Dear students, allow me please to continue teaching you the statistics. Right now we are in unions and intersections. The union, there are 2 points for the union. The outcomes on either events A or B or both, or statement donated by you. Symbol. This is the symbol for the union. For example, A union B. The intersection, there are 2 points for the intersections. Outcomes in both events, A and B. A and B. And statement donated by you, but in the upside down, this is the symbol for the intersection. For example, A intersection B. 3. The given P and B given that A has accurate, which means that A is the correct one and P is the given. There is a special notation for this P times P intersection A. Discrete and continuous variables. Discrete random variables have a countable number of outcomes. For example, when you roll a die, the possible outcomes are 1, 2, 3, 4, 5, or 6, but not 1.5 or 2.45. Final description and the in Poisson distribution are discrete probability distributions. The continuous random variables have an infinite continuum of possible values. For example, the weight of a girl can be any value from 45 kilogram or 45.5 kilogram or 45.5436 kilogram. The laws of probability. There are two main laws. The first one, probability provides the basis for all the tests of significance. Second one, it is estimated usually on basis of following 5 laws of probability. The first one, additional law of probability, multiplication law of probability, final law of probability, distribution, probability chances from shape of normal distribution or normal curve. Additional law of probability, mutual exclusive. If one event excludes the probability of occurrence of the other specified event or events, the events are called mutual exclusive. If two events are mutual exclusive, then the probability of either occurring is the sum of the probabilities of each occurring. For example, P times A or P equals P times A plus P times B. This is a simple or easy equation. Example, chances of odd or even number. This is the odd and this is the even number. The additional law of probability, mutual exclusive. Example, king or queen. In a deck of 55 cards, the probability of a king is 1/30. So P times king equals 1/30. The probability of a queen is also 1 over 30. So P times queen equals 1 over 30. When we combine these two events, the probability of a king or a queen is 1 over 13 plus 1 over 13. That will be equals to 2 over 13, which is written like this. P times king or queen, either one of these, equals 1 over 30 plus 1 over 30 equals 2 over 30. The additional law of probability. Two mean mutual exclusive events. Two or more events can occur simultaneously. For example, the occurrence of one does not prevent the occurrence of the other. The occurrence of one does not prevent the occurrence of the other. Second one, in events which are mutual exclusive, uh, there is some overlap. Example, uh, P equals P times A union P equals P A plus P B minus P A intersection B. This equation is the mean. This equation is the meaning of this speech, which is the occurrence of one does not prevent the occurrence of the other. For example, the chances of an odd number, which is less than 4. What we have odd number less than 4. We have 1 and 3. Example, hearts and king. The multiplication law of probability. This law is applied to two or more events occurring together, but they must not be associated. Example, must be independent of each other. Must be independent of each other. That means they have to be separate for each other. According to the multiplication law of probability, the probability of occurring of two independent events is equal to a product of the probabilities of those events separately. For example, P times A and P equals P times A times PB over A. Multiplication law of probability. This law is applied to two or more events occurring together, but they must not be associated. Example, must be independent for each other. According to the multiplication law of probability, the probability of occurring of two independent events is equal to product of the probabilities of those events separately. P times A and B equals P times A times P B over A. Multiplication law of probability. Example, what is the probability of random drawing a card from the dark? That is an ace and a heart. P A and B equals P A times P B over A, or intersection to A. The P A's and heart equals P A's or times P heart or intersection A's equals 4 over 45 times 1 over 4. That will be equals 1 over 52. Frequency distribution. To describe the situations, draw conclusion, or make influence about events, the researcher must be organized the data in some meaningful way. The most convenient method of organizing data is to construct a frequency distribution. That is the meaning of frequency distribution. Describe the situation, draw conclusion, or make influence about events. The researcher must be organized the data in some meaningful way. The most even a convenient method of organizing data is to construct a frequency distribution. We have an example with people. Suppose the research wish to do a study on a age of the top 50 wealthiest people in the world. The researcher first would have to get the data on the ages of the people. In this case, these ages are listed in Forbes magazine. When the data are on original form, they are called raw data and are listed next. These are the raw data which are listed. Class limit, tile frequency. These are what we have. We have 35 from 35 to 41 and 42 to 48. We have three people, and these are three people. And 59 to 55, we have four, and these are the until total of 50. Now, some general observation can be made from looking at the frequency distribution. For example, it can be stated that majority of the wealth people in the study are over 55 years old. Over 55 years old. Distribution of blood types. 25 army indicates were given a blood test and determine their blood type. The data set is these are the blood types, construct a frequency distribution for the data, which we have APOAP. We have 5794. So total 25. The percentage 20, 28, 36, 16. So the majority of the people are 36. For the sample, more people have type O blood than any other type. Probability distribution. A probability distribution describes how the outcomes of an experiment are expected to vary. Since such distribution deals with the expectations, they provide useful models in making influence and decision in the face of uncertainty. Example, the first requirement state that some of the probabilities of all the events must be equal to 1. The sum cannot be less than 1 or greater than 1, since the sample space includes all possible outcomes of the probability experiment. The second requirement states that the probability of any individual events must be value from 0 to 1. The reason, as stated in chapter 4, is that range of probability of any individual value can be 0, 1, or any value between 0 and 1. Probability cannot be a negative number or greater than 1. Rolling a die. Construct probability distribution for rolling a single die. Solution. Since the sample space is 1, 2, 3, 4, 5, 6, and each outcome has a probability of 1 over 6, the distribution is as shown. The outcome x 1, 2, 3, 4 until 6, the probability px 1 over 6 1 over 6, 1 over. That means the probability which we have is that from 1 until 6. So 1 over 6. The probability distribution can be shown graphically by representing the value of x on the x-axis and the probability px on the y-axis. Choosing coin represent graphically the probability distribution for sample space of choosing 3 coins. Number of hits x 0, 1, 2, 3, and probability px equals 1 over 8, 3 over 8, 3 over 8, 1 over 8. The solution, the value that x assume are located on the x-axis, and the values of p-axis are located on the y-axis. The graph is shown in figure 5 to 1. This is the graph. The probability here and the number of heart. Probability distribution. Determine whether each distribution is a probability distribution. X and px 0 to 20, 0, 5, 10, 15, 20. So that means 1 over 3, 1 over 3, 1 over 3, and 1 over 3. P and px from 0 to 6. So we have negative 1, 1.5, 0.3, 0.2. C, px 1, 2, 3, 4, 1 over 4, 1 over 8, 1 over 16, 19 over 16. D, x and px 2, 3, 7, 0.5, 0.3, 0.4. Solution, yes, it's a probability distribution, which we have all the px are the same. No, it's not probability distribution, since px cannot be 1.5 or less than 1 or negative 1. We have negative 1 and we have 1.5. C, yes, it is a probability distribution. So we have 1 over 4 time, that will be, if we multiply 1 over 4 with 1 over 4, we will have 1 over 18, and 1 over 16, 9 over 16. No, it's not, since summation of px equals 1.2. If we sum these, we will have 1.2. For exercise 6 through 11, determine whether the distribution represents the probability distribution. If it does not state why. Px equals 1, 2 over 11, 5, 1 over 11, 6, 3 over 11, 8, 3 over 11, 10, 1 over 11. 7, x and px 3 over 0.3, and 6 over 0.5, 8 0.7, negative 12, 0.5. So we have this, the number 7 is not probability because we have negative 0.8, and this one we have 0.3. That will be not probability distribution. This is a probability distribution, and if we calculate both these, we will have probability distribution, but this one is not probability distribution. This one is probability distribution. Question 1. The owner of a bakery may be considering how much 1 kilogram cakes he can sell in a day. He has kept record of the sale of this type of cake made over last 100 days. We have number of cakes sold which is x, 1, 2, 3, 4, 5, 6. And the number of days, which is f, we will have in 10 days, in 20, in 20, in 35, in 10, and 5. That will be total of 100. Based on these historical data, develop probability distribution of demand for the cake in question. The answer: number of cakes from 0 to 1, and probability, which is 0.10, 0.20, 0.20, 0.035, 0.10, 0.05, which is here. The probability is the same with the percentage. It's the same with the percentage. So 10, what's the percentage of 10? It will be 0.1. What's the percentage of 20? 0.2. What's the percentage of 35? 0.35. And 5, percentage is 0.05. Types of probability distribution: discrete probability distribution, binary distribution, Poisson distribution, and continuous probability distribution, inform probability distribution, exponential probability distribution, normal probability distribution, students distributions, chi-square distribution, F distribution. These are the type of continuous probability distribution, and these are the type of discrete probability distribution. Binary law of probability distribution. A binary distribution can be through of as the probability of success or failure outcomes in an experiment or survey that is repeated multiple times, can be true of as the probability of a success or failure outcomes of in an experiment or survey that is repeated multiple times. Probability of success is P. Probability of failure is 1 negative P. Example: the four possible outcomes that could occur if you flip a coin twice are listed below in a table. 1, 2, 3, 4, heads. The first flip, heads. The second and the third one, tails, and the fourth one is tails. These are the second flip, head, tail, head, tails. Number of heads, 0. Probability 1/4, and 1 equals 1/2, and 2 equals 1/4. Formula of binary distribution: we have fx equals c power of n times p power of x q power of n minus x, where r the number of success that result from the binary experiment, n number of trials and binaries, p probability of a success of an individual trial, the q probability of failure on an individual trial, p and x binary probability. Second question: fit binary distribution to following distribution of 156 samples. Number of defective items: 7, 6, 5, 4, 3, 2, 1, 0. Number of samples: 1, 6, 35, 36, 48, 24, 7, and 2. The answer: the number of detective items: 2, 6, 5, 4, 3, 2, 1, 0. So expected frequency: 1.22, 8.53, 25.6, 42.65, 48.65, 25.6, and 88.53, 1.22. Paschen distribution. It is a discrete probability distribution of the number of events occurring in a given time period, given the average number of times that event occurs over the time period. It is a discrete probability distribution of the number of events occurring in a given time period, given the average number of items that event occurs over that time period. For example, a certain rest, uh, fast food restaurant gets an average of 3 visitors to the drive-through per minute. This is just an average. However, the actual amount can be varied. No of accident per year in this district of Maharashtra. A number of type error per beach, and number of vehicles passing a certain point per minute. Patient distribution. Conditions for patient distribution. We have 3 conditions. First one, an event can occur any number of times during a time period. An event an event can occur any number of times during any time period. Events occur independently. Events occur independently. The probability of an event occurring is proportional to the length of the time period. Patient distribution. Example: the number of phone calls an office would receive during the known hour. Average 4 calls per hour. Through the average is 4 calls, they could theoretically get any number of calls during that time period. The events are effectively independent since there are no reason to expect a caller to affect the chance of another person calling. The probability of getting a call in the first half hour is the same as the probability of getting a call in the final half hour. The formula for Paschen distribution equals uh, fx equals exponential m power of negative m power of x over x. A constant which is equals to approx 2.71820. This is constant number. M mean number of success that occur in a specific region. X actual number of success that occurring in a number of specific region. PXM the Paschen probability that exactly X success occurring in a Paschen experiment when the mean number of success is mu. This is the mu. Question 3. If 4% of electric geysers manufactured by a company are defect, use the Paschen distribution to find the probability in a sample of 100 gears. When number of defective and 5 geysers are defective, given e power of negative 4, which is equals 0.018. The answer P0 equals 0.018. 0.18 and P5 equals 0.154. The normal distribution or normal curve. The normal probability model applies when the distribution of a continuous outcome conforms reasonable well to a normal of a Gaussian distribution which which is resembles a pole-shaped curve. Frequency, percent, and body weight. This is the curve. Number of probability distribution. A family of continuous probability distributions described by the number of equation is called the normal distribution. A family of continuous probability distribution described by the number of equation is called the number of distribution. Normal distribution is defined by the following equation, which we have y equals fx equals to 1 over a root 2 pi multiply with the exponential power of negative 1 over 2 mu power of 2 x negative mu power of 2 where e is a mathematical constant equal to 2.7183 mu expected value of mean standard deviation. This is the standard deviation. X a particular value of random variables and it is infinity x and plus infinity. Standard normal distribution. The normal distribution with standard deviation equals 1 and mu equals to 0 is called standard normal distribution. In fact, it's possible of convert any number random variable x, not a standardized normal variable z. This is called z transformation, and this is done by the following formula: z equals x negative x minus mu over standard deviation. For example, question 4, 2000 applicant appeared in an interview. Distribution of makers is assumed to be normal with the mean mu equals 30 and standard deviation equals 6.25. How many applicants are expected to get marks? Between 20 and 40, less than 30 and 5, above 50. Answer 1422 for the 240, and the 35 is 42, 424, and third one, which is the above 50, is 1. Homework question. The homework question, the bullets product by a certain machine were checked by examining sample. If 12, the following table shows that distributions of 130 samples to occur according to the number of defective they contain. The defectives in a sample from 0 to 7, and number of samples 7, 6, 19, 35, 33, and 28. Find the binary distribution and find the expected frequency. If a chance of a bolt being defective is 1 over 2, find the mean and variance of the fitted distribution. Assume that on an average 3% of output a factory manufacturing water filters are defective in a package. What is the probability of that? Uh, None is defective. The most 40 defective given e power of exponential power of negative 9 equals 0.000001234. The The answer for this question of the homework, this one will be 0.7, 0.6, 0.19, 0.30, 0.39, 35, 0.3, 0.23, 0.08, 0.02, which is, and we will have the defective 1 over 7, 1 over 6, 1 over 19, 1 over 35, 1 over 30, 1 over 23, 1 over 8, and 1 over 20. Assume that an average 30% of output of a factory meaningful water, that will be 0.03, and we can, given the most defective with this equation, and we can get the defective answer, which is if x equals exponential power of negative mx and x. Now is the characteristics of normal distribution. Approximately 68% of the values fall between mean and non-standard deviation in either deduction. Approximately 95% of the values fall between the mean and two standard deviation in either direction. Approximately 99.9% of the values fall between the mean and three standard deviation in either deduction. So these are percentage of case in 8 potential of the value of the curve. So we have this and the standard deviation cumulative percentage. Example, in a date of for a height of all adult men alive today, the mean height was 69 and with the SD of 30 inches, which is in probability that the mean will be between 66 and 72 inches tall, or within one plus or minus one standard deviation of the mean. There is 68% probability p equals 68, 0.68, that any one man was selected, we select will fall within this range. Similarly, the probability of selecting a man of 78 inches or taller scores beyond plus 3 standard deviation is 0.0013, as this area represents 0.13% of the total distribution. We can see here 0.30% is at the end, and 68.26 standard is the high inches. Feature of normal distribution. There are 7 listed below. Normal of distribution are symmetric and around their mean. The mean, median, and mode of a normal distribution are equal. The area under the normal curve is equal to 1.0. Normal distribution are denser in the center of less dense in the tails. Number of the normal distributions are defined by 2 parameters: the mean mu and the standard deviation. 68% of the area of normal distribution within one standard deviation of the mean. Approximately 95% of the area of the normal distribution is within two standard deviation of the mean. These are the two curves of normal distribution, different means, same standard deviation. Normal distribution, same means, and different standard deviation. So we can see the curve. Non-normal distribution, uh, normality is a myth. It never was and never will be a normal distribution. Report C, Gray, quoted from testing from normality. Types of non-normal distribution: beta distribution, exponential distribution, gamma distribution, inverse gamma distribution, log normal distribution, logistic logistic distribution, Maxwell Boltzmann distribution, Paschen distribution, Scout distribution, symmetric distribution, uniform distribution, unimodal distribution, and Weil-Ball distribution. Reasons for for the non-normal distribution: there are four reasons. Uh, Outliers, they remove any extreme high or low values and testing your data again. Multiple distributions may be combined in your data, giving the appearance of a biomodal or multimodal distribution. For example, two sets or normal distributed test results are combined in a graph. Insufficient data can cause a normal distribution to look completely scattered. An extreme example: if you choose three random students and plot the result on a gray graph, you won't get a number distribution. You might get a uniform distribution. Example: 62, 62, 63. Or you might get a Scout distribution: 8, 80, 92, 99. If you are in a doubt about whether you have a sufficient sample size, collect more data. Data may be inappropriately graphed. For example, if you are in a graph people's weight on a scale of 0 to 1000 label, you would have Scout clustered to the left or graph. Make sure you are graphing your data on appropriately label axis. Thank you so much, and that's the end of this lesson. And thank you so much for your understanding and for your listening.